So we're going to be learning about the centre of mass of an object. To start off with, let's think about what we mean by mass. So the mass of an object is really the measurement of the matter that is inside of it. So by matter we mean particles. So if we consider this ruler, it's made of stuff, it's made of atoms, of particles, so therefore it is made of matter. And the measurement of how much matter is in this ruler is called mass. So the centre of mass, by definition, is where the mass, so the point where the mass can be thought of being concentrated. So it's one point where we can consider the mass to be thought of as being concentrated. And there's a way that we can test this, which I can show you with this ruler. The centre of mass is going to be, for a regular shape like this, it's going to be in the centre. So if I hold this ruler balanced on my finger at its centre point, it balances, and that's because there's the same amount of mass on this side as on this side, so it gets balanced through this centre point. So if it is a symmetrical object, then it is going to be along the axes of symmetry. So you'll have done about symmetry in maths, and we can show you with a square post-it note. So we can think about axes of symmetry. If I fold it in half like this, then this crease down the middle is one axis of symmetry. If I fold it again, so the centre of mass will be somewhere along this line. If I fold it again, so another axis of symmetry, then the centre of mass is now somewhere along this line, and actually those two lines cross over in the centre. So for this post-it note, the centre of mass will be right in the centre, which means that we should be able to balance it. Okay, so that balances on one finger through this central point because that is the centre of mass. And this would happen with any object where there is that symmetry. So we'll just draw these lines on. Obviously I should use a ruler, but let's just sketch them for now. So the centre of mass is going to be where those lines cross over. If we hang an object, so if we suspend something, so suspend just means to kind of hang an object, it will come to rest with the centre of mass underneath. Okay, so again I can show you this. I've got a bit of tape attached to a string, so if I hold the string and just let it hang, the tape hangs directly underneath this string. Now if I displace it, so move it from its rest position, called its equilibrium, then what's going to happen is it will swing and then it will come to rest in that equilibrium position. So let's write that. So if it is displaced, it will swings back to its equilibrium or rest position. So you have to be able to show where the centre of mass is on something that is a symmetrical shape, but also you need to be able to know how to measure the centre of mass on something that is an irregular shape, so it's not symmetrical, and I'll show you how to do that now. So what I've got here is a screwdriver, which I'm going to hang my shape from, and then I've just got a piece of string with something to kind of pull it straight. So this tape at the end is just going to make this string hang directly vertically below this point here with the screwdriver. So if I hold it like this, if I hang this irregular object, then what's going to happen is it's going to swing until the centre of mass will be directly below it, somewhere here. So what I can do is I can just mark on here where the string comes out. It's quite hard to do while it's hanging. So if I just mark there, I know that it's going to be somewhere between, on the line between this mark and this hole. If I then move it to this hole and let it go, it's going to hang again. So I'll make a little mark. I'm going to join these marks up in a minute. Move it to the next hole and let it go. And again mark where the string comes out. And then move it to the next hole and let it go. And mark at the bottom where the string comes out. So now we're going to join these up and find where our centre of mass is. Now we have our shape from where it's been hung, and we can see where the dashes, where the string was leaving, are opposite each of our holes. So we're just going to connect them up with a ruler, and then you'll be able to see where the centre of mass is quite clearly from this. So we should be able to see from here that the centre of mass is right where all of these lines cross over. You are able to draw the whole lines whilst it's hanging if you want to, but sometimes it can be quite tricky, especially if you haven't got a clamp stand to hold it onto. So doing it with a ruler from the hole to the place where the string kind of came out the other side is another way that you can do it. So the centre of mass for this object is going to be right where these lines cross over. Sometimes the lines don't cross over exactly, and that's because sometimes it can't freely hang from the hole. So the hole that we've used here is quite a lot bigger than the screwdriver that it was hanging from. So when we put the piece of card on the screwdriver and let go, it does hang quite freely, whereas if the hole is a bit smaller, then sometimes it doesn't hang quite so freely and your results might not be exactly perfect. But give this a go with stuff that you've got lying about in your house, and hopefully you'll be able to find the centre of mass of an irregular object.